Okay, Algebra 1. This first equation here is example 2 on page 643. Okay, we'll get to this one in a second. We will solve it similarly, but the first one is example 2 on page 643. So um, now we have a radical symbol in an equation. Okay, the good news is we already know what to do. We already know how to solve equations. We have 2 steps. Those steps are to do the opposite and then to do it to both sides of the equal sign. So one thing I want to point out is what we need to do first is we need to make sure that the radical symbol is by itself on one side of the equation. So if you look on the left side of this equation, we have a radical, but we also have this plus 7. So we need to move the 7 by doing the opposite to both sides. Okay, so here we have radical, and I'm just going to write it over here. Okay, so we have radical a plus 5 equals 12 minus 7 is 5. All right. Now, obviously, the left side of the equal sign, the only thing that's there is the radical. So that's what I meant by get the radical by itself. Okay, is to do what we've done. All right. So what is the opposite of square rooting something? Well, it's squaring, right? If we square this, the radical symbol will cancel and we'll be left with a plus 5, right? We'll be left with a plus 5. And if we square the thing on the left, we will also square the thing on the right. 5 squared is 25, right? Yes. So, from here, all we do is subtract 5, and we will be left with 25 minus 5 is 20, right? So A here is 20. Okay. That one should be relatively clear cut. This other one has some multiplication in it, which is why I wanted to look at it. This is number 19 on page 644. This is number 19 over on 644. So if you want to flip over there, that's where you can see this problem. Once again, we need to get the radical by itself first. So that means I have to move the 5 and the 4. And the question is, what moves first? Well, it's the 4. We're going to go ahead and subtract. Always do addition and subtraction before multiplication or division. It's like the reverse of order of operations, right? We'll get rid of these things first. Okay, so these cancel, and now I'm left with 5. Radical a minus 3. That's equal to, that's 10. Okay, well, how do we get rid of the 5? Well, what is happening between the 5 and the radical symbol? They're timesing. The opposite of times is divide. So divide both sides, and we're left with, and I'm going to write this over here, we have radical a minus 3 equals 10 divided by 5 is 2. So, I guess now we have the radical by itself, and this is where we're going to square both sides. Remember, we squared it up here and down here. And remember, the whole point of the squaring is we want to get rid of the radical, right? The square cancels with the radical. Those things no longer exist, and we're just left with a minus 3. And 2 squared is obviously 4. Okay, so if I add 3 to both sides, 4 plus 3 is 7. All right, so number 19 was 7. All right, let's look at one more here. And this one's going to be a little trickier, but we will be okay. Okay, so I have a radical in an equation, but I also have a k on both sides. So let's look at the k on the left first. Okay, so this k is in an inequality, or sorry, that was early morning for me. That was a radical symbol, not an inequality. So we got the radical by itself. Let's go ahead and square it. Okay. Now, we know when we square, like we just practiced, this radical symbol in the square will cancel. So I'm going to be left with k plus 1 over here. But when we square this thing, okay, this thing right here, when we square this binomial, it's not just k squared minus 1 squared. This is a binomial, and when we square a binomial, I want to bring your attention to the FOIL method. remember, squaring is really timesing something by itself. Okay, so the difference is, if you look back at my first sheet, we were squaring a 5. That's a monomial. We just squared one number and it became 25. We squared a monomial, 2, and it became 4. But here we're squaring a binomial, so that means we will have to use the FOIL method. Okay, so hopefully you guys remember FOIL, right? First, outside, inside, last. Let me get some different colors here. So the first number is k and k, right? K times k is k squared. The outside, O, right? O is the k and the negative 1, which is minus k. On the inside, we have, this is also a purple, yuck, sorry. It's like a slightly lighter purple. The inside is this, and this we got negative 1 times k, which is still negative k. And then the last thing that we have is the L, which is last, negative 1, positive 1. And if we look at this, the middle two terms here, we know that we can combine these terms. We have k squared here from right there. Negative k minus k is a negative 2k. Remember, these are like 1k's, right? They're like a negative 1 minus 1, negative 2. And then I have a plus 1 over here. Okay, so don't forget that this was the FOILed version of this thing, right? When we squared this binomial, we got this trinomial, which was k squared minus 2k plus 1. And when we look at this equation, I'm going to go ahead and just kind of circle it in red here. This equation, yuck, we have a k squared, we got k's on both sides. I want you to think for a second what type of problem this will be and how we can solve it. Well, if we have a k squared, okay, that tells me this is a quadratic, and right, it's going to give us a parabola, quadratic. So if you remember, before COVID-19 took over the world, we talked about quadratics, and there were 4 ways to solve. We could, there were multiple ways to solve. We could graph them, right? We could factor. We could use quadratic formula. We could complete the square. And I think factoring probably will be our first option here. Okay, so let's move the k and let's move the 1 over here. Let's move those over by subtracting. Basically what I'm going to do is I'm going to set this equation equal to 0 so I can factor it. All right, so I've got nothing left over here, so that's equals 0. I have a k squared. Now I have 2k minus k, which is a minus 3k. And then I have a 1 minus a 1, which is obviously 0. Okay, so this cancels. Now we're left with a binomial. Okay, so this one's tricky, and I chose this one specifically to look at because we can't factor this. It's not a, I mean, we can factor it. We can't factor it like a trinomial. What we can do is we can factor it like a binomial. So the method to factor binomials was look for a greatest common factor. And in this case, it is k. If I took a k out from both sides, I would be left with k minus 3. Remember, factoring is like division. So if I say k squared divided by k, well, there were 2. We took 1 out, so there's 1 left. And if I have a 3k divided by k, the k's cancel, right? We take 1k out, and we're left with just the minus 3. This is still equal to 0. So, and this might be the part that you forgot a little bit, but if we have polynomials that equal 0, remember, this is a monomial, and this is a binomial. If these two polynomials equal 0, we just set them equal to 0. I'll say k equals 0, and then this one I will say k minus 3 equals to 0. Remember, we just kind of put what's in the parentheses equal to the 0 here. So I got k minus 3 equals 0, and I got k equals 0. This one's solved. This one is not. So I have to add 3 to both sides, and that gives me k equals 3. So we have 2 answers here, but we're going to take a quick pause Okay, so the last thing we need to do then is check our answers. Okay, we got to check our answers because the radical symbol changes some things. Okay, and we'll check by plugging our answers into our original equation up here. So I'm going to rewrite it like this: k plus 1 equals, or is radical k plus 1 equals k minus 1. All right, so if we plug a 3 in, right? If we plug a 3 in, okay, so 3 plus 1 is 4. What's the square root of 4? It's 2. And then if we say 3 minus 1, that is also equal to 2. So this one works out, right? 3 is good, right? 3 plus 1 was 4. Square root of 4 was 2. And then 3 minus 1 is also 2. Over here, though, when we plug the 0 in, watch what happens this time. I'm going to switch to the red. We plug the 0 in. What's 0 plus 1? Well, it's just 1. And the square root of 1 is still 1, right? Okay, if we plug in 0 over here, I'm going to leave it with the square root symbol, actually. All right, so 0 plus 1 was square root of 1. 0 minus 1 is a negative 1. All right, so look at what it's telling us to do, right? Can a radical symbol equal a negative? Can a square root equal a negative? Well, the answer is no, right? You could also say that the square root of 1 is equal to 1, right? And then this is still negative 1, so 1 does not equal negative 1. This one does not work. Our only answer is k equals 3. Okay, guys, so I'm going to show you one more problem of factoring here. This is 3a at the bottom. I'm going to go quickly here, but this will be factoring a trinomial. All right, so I've got t plus 5 equals to t plus 3. Remember, we're going to square both sides, okay? Only when the radical's by itself. Okay, so we'll square this, and we will square this. So this cancels. We're left with t plus 5. When we square this binomial, we have to FOIL. Remember, foiling is how you square binomials. It's this times itself. First outside, inside, last. I'm going to FOIL this very quickly, okay? So I've got t squared plus 3t plus another 3t. And then the last thing would be plus 9. And I know that 3t plus 3t is 6t. So I want to come back over here. I'm going to write t squared plus 6t plus 9. All right. And the reason I chose this is last time we had a binomial. This time it will be trinomial factoring. Let's move the t and the 5 over towards this side. I will say minus t. I will say minus 5. Remember, we're setting it equal to 0. The t's cancel, 5's cancel, 0 is left. I have t squared. 6t minus t is a plus 5t. And 9 minus 5 is plus 4. Okay, here's that trinomial as promised. I want to show us how we factor this. Remember, we use our sets of parentheses. Plus plus gives us plus plus. Since a is 1, we just have a t here and here. Still equal to 0, by the way. And now we need the factors of 4 that add to 5. Obviously, it's 4 and 1, right? 4 times 1 is 4, but 4 plus 1 is 5. So that's how you factor that trinomial. Remember, when we have two sets of parentheses or we have two polynomials that equal 0, we set them both equal to 0. All right? We'll subtract 4 on both sides, which is t equals negative 4. And we subtract 1 here, and we get t equals negative 1. Now, remember, we must check our answers. Oops, must check our answers here, okay? This one and this one. So let's go back to our original, which was t plus 5 equals t plus 3. Let's use negative 4 first. Negative 4 plus 5 is the square root, negative 4 plus 5 is 1. So we have the square root of 1 here. And then negative 4 plus 3 is a negative 1. We know that the square root of 1 does not equal negative 1. You can't have a square root equal negative. This one does not work. Let's check, right, because both of them could be no good. Let's check the negative 1 here. What's negative 1 plus 5? It's 4. Square root of 4 is 2. What's negative 1 plus 3? 2. This one works. Okay, so our answer here is t equals a negative 1. All right, so I know that last example was fast. It is the exact same as example 3 that we did, with the exception of at this stage we had a trinomial to factor. Okay, guys, I want you to try some problems for me here. Go to page 644, numbers 3, 5, and 7. Go ahead and try those 3. If you have any questions, let me know. Otherwise, I will see you back here tomorrow. Good luck.